Page 2. I hate how boring I feel and sound when nobody else is here. Cool. Well, boring or not, here we go. For the z-scores below, find the percentile rank, the percent of individuals scoring below. This is literally just taking this, using table A, and finding the percentile that we read straight off the table. So I'm going to go look at negative 0.47, negative 0.4, over to 7, and I get 0.3192, and that is the answer that we are looking for. Wait, what was it? 0.3192. And you can write that as 31.92% if you wish, but Stats doesn't care. You can write it either way. Both are correct. Doesn't matter. Okay, 0.22 or 2.24. That's going to be a high percent. 2.2. Oops, that's negative. 2.24. 0.9875. Or if you really want to take an extra step, 98.75%, or really close to 99%. Okay, now how did we get away with that so easy? It's asking us to scoring below. The next one is saying falling above. So I don't know that I feel the need to draw this, but definitely I'm going to have to take into account that the number on the table is always the below value. Okay? So I'm going to have an extra step here. So I'm going to look for 0.24 on the table. 0.24. So 59, almost 60%, about 59% falls below this z-score. How much falls above? Well, that's going to be 1 minus the value we got, 0.5948, which is, let's see, what is that? 0.4052, I think, if my head math is correct. Now I can check that. There's an easy way to check that, because the amount above this value is exactly the same as the amount below the negative z-score of 0.24. So I'm going to look. Negative 0.24, ah, there it is, right there, 4052. Why is that? Because the curve is symmetric. All right, sweet. So above negative 2.07, this is going to be a 1 minus again, but I'm going to find the percentile for negative 2.07. Negative 2.07. I've got 0.0244, so about 2%. So that's going to be 0.9756 is the value I'm looking for. And why do I have to do the 1 minus? Because the table doesn't give me the above values. I have to get that from taking the whole minus the part. Or I can check that by changing the sign and go to 2.07. 2.07, what did I say, 0.9808? Did I look that up right? I might have made a mistake. Yeah, I made a mistake on the last one. I dropped down one number accidentally. So that should be 0.0192, or about 2%. So I'm going to change this guy. Which would be 0.9808, and that is a check for my 2.07. Cool. Caught a mistake. I love it. Okay, here's where standardizing comes in and answers questions great. A patient is recently diagnosed with Alzheimer's, and we have a score. The patient scores 45. The mean is 52, and the standard deviation is 5, and that's all I need. X minus mean over standard deviation gives me a Z, and I can take that to a percentile rank. So this is going to be 45 minus 52 divided by 5, which is going to be 7 divided by 5. Oh, that's a negative 7. I better catch that. That's a big difference. So I get negative 1.4 for Z. That's not the answer, but that's going to take me to the answer. Negative 1.4 is 0.0808. Or to put that in another term, a little more than 8% of the population who take this test score below this person, below the 45. So that's a pretty low score. All right, fifth grader takes a standard achievement test with a mean of 125, standard deviation of 15, and that youth scores 148. I'd say that's a pretty good score. So what's the percentile rank? The score minus the mean divided by the standard deviation, and I'm going to get a Z for that. Be careful. Let me show you a mistake that I see students make. If you do 148 minus 125 divided by 6, you're going to get an answer that doesn't make any sense. So this is an order of operations problem. 127 standard deviations away from the norm. I can't say it's impossible, but I don't think so. So what happened? The 6 divided the 125 before it was subtracted from the 148. So I'm going to do 148 minus 125 equals, divide that by 6, and I get, ooh, wow, that's a really large standard deviation. 3.83. And that doesn't fall on our graph. I don't have a 3.8. I don't even have a 3.5. So what's the probability of being more than a 3.49? Almost 0. So what is this guy's percentile rank? It's more than the highest score on our table of 0.9998. Okay, that's this child's score. So more than 99.98%. So I told you couldn't have 100%, but I didn't say you couldn't get real close. All right. Pat and Chris took a spatial abilities test. We've got a mean and a standard deviation. Man, anytime I see these, mean and standard deviation, I think standardizing. Every time. Pat scores a 76. Chris scores a 94. What percent of individuals would score between Pat and Chris? All right, well, again, I could definitely draw a curve here and it might help me understand this. Pat's a little bit below the mean. Looks like Chris is quite a bit above the mean. Let's see if we can just standardize this. I need to do it both. So I need Pat is going to be 76 minus 80 divided by 8, which is a negative 4 divided by 8, right? Which would be a negative 0.5 for a z-score. I'll look that up here in just a second. Chris is 94 minus 80, his score, minus the mean, over 8. And that's going to be 14 divided by 8, which is 1.75. So I've got a negative 0.5, I'm sorry. So Pat's percentile rank is about the 31st percentile, 0.3085. And Chris, let's say, did quite well at a 1.75. That puts him in about the 96th percentile, 0.9599. So what's the percent of people that scored between them? Well, that's going to be the 9599 minus the 0.3085. And it's getting late in the day. I'm too lazy to do that in my head. So about 65% would score between the two. So 65% of the class or the test takers or whatever scored between Pat and Chris. All right, normal distribution of scores has a standard deviation of 10. Find the z, so that's constant here. Find the z-scores corresponding to the following values. A score of 60 where the mean is 40. So 60 minus 40 divided by 10, that's 20 divided by 10, which is just simply, that looks like a z. That's a 2, and that is the z. It's not asking for the percentile rank, it's just asking for the z-score. Probably should circle that like that. A score of 30% points below the mean. So we're going to continue to use our mean of 40 for the next one. So 30 points below the mean, that would be 10, right? That person scored 10 points minus the mean over 10, the standard deviation that isn't going to change. So that's negative 30 over 10, which would be a negative 3 for our z-score. All right, a score of 80 where the mean score of the sample data is 30. So the mean is 30, the score of 80. This is going to be a really big one. It can happen. It just doesn't fall on our table. So this is going to be 50 minus 10, which would give us a z-score of 5. Or almost 100% would fall below that value. Okay, and the last one, oops, sorry, I'm kind of dipping a little low there. The last one, we've got a mean of 50. I've got a score of 20, so I've got to do 20 minus 50 over the standard deviation of 10. That didn't change throughout any of these problems. 20 minus 50 is a negative 30 divided by 10 would give us a z-score of negative 3. Now I could change all of those into percents very quickly by just going to the table, which is totally cool. The only one that's going to give us problems is that. You just have to recognize that this is approaching 1. This approaches 1 or 100%. Is it 100%? Nope, but it's close. Really close. All right, I hope that wasn't too boring. Thank you for your patience and your time. I hope this makes a little bit more sense on this, and we will continue to get practice through pretty much the rest of the year with standardizing. So we want you to get comfortable with it. And I'm glad you're here.